In 1654, Pascal used probability to solve a gambler's dispute. And in 2020, we're going to do the same with a pandemic. The basic reproduction number, or R0, is a measure of pathogen fitness commonly used to model the spread of infectious diseases. It is defined as the number of new infections that an existing infection is likely to produce.
R0 is calculated according to the following equation, where beta is the transmission rate, the contact rate multiplied by the risk of infection given contact, and n is the number of susceptible people a sick person can potentially interact with. Beta n is then divided by alpha, the odds that a host dies from infection, plus delta, the odds that a host dies from natural causes other than infection, plus gamma, the odds that a host recovers from infection.
If R0 is less than 1, this means that each infected individual is, on average, not producing any new infections. The disease is not spreading. But if R0 is greater than 1, each infection is producing at least 1 or more new infections, leading to exponential growth of the disease, a pandemic. The estimated R0 for COVID-19 is between 2 and 2.5, meaning every person that gets COVID-19 is likely to infect 2 or more people. We can try to reduce R0 by limiting beta through social distancing, but the best way to reduce R0 is by reducing N, the susceptible host population, through vaccination. By vaccinating, you not only protect individuals from getting sick, but you also prevent the possibility of a pandemic through a phenomenon called herd immunity. Using R0, we can specifically calculate the exact proportion of the population that needs to be vaccinated in order to achieve herd immunity. Let's say P is the proportion of protected people in the population, then 1 minus P is the proportion of susceptible people left in the population. Protected people have an R0 of 0 because they produce no new infections, but susceptible people have the regular R0 of the disease. The average R0 of the disease is then the proportion of protected people times 0 plus the proportion of susceptible people times R0. Because we want our average R0 to be less than 1, we can make this equation an inequality. Rearranging this inequality tells us that the proportion of protected people must be greater than 1 minus 1 over R0. We can call this value the critical proportion of protected people, PC. If we can reach PC by vaccinating enough of the population, we can know with certainty that R0 will be less than 1 and the disease will not spread. PC for most diseases is within the 90 to 95% range. Since some individuals can't get vaccinated due to differing health concerns, it is our responsibility as healthy individuals to get vaccinated. Pascal once said that in each action, we must look beyond the action at our past, present, and future state and at others whom it affects. Vaccines only work if we all get them. Our future and our not are in our hands.